From ContainerDays Hamburg, this video is proudly presented by Dux IT.
So my name is Ronny. I am from India. I work for Kubernetes. I lead one of the engineering teams at Kubernetes. I also work with a lot of customer projects in terms of on consulting capacity. I also work quite actively on our managed services division, which basically means that we take end-to-end care of our customer environments. I also do a little bit of training. I like a little bit of public speaking, although I don't think I'm really good at it, but I really like speaking. I like sharing whatever little bit I know. So yeah, that's mostly it. If I have to summarize myself, what I have been doing for the last few years. And this community of open source is also pretty new for me. I think I have been in the industry for, I don't know, maybe 10 to 12 years. And I'm actually embarrassed to say that I got involved, or I became quite familiarized with open source in the last year. Once I became part of Kubernetes. Before that, I was working with a couple of really proprietary companies. So I wouldn't blame myself or the company that I wasn't exposed to too much of open source. But it's never late or never too late for open source. So finally, so from last year, I have been quite active in the open source space in terms of using things that make my lives easier. So one of the tools that I have been using quite extensively is KubeVirt. Which has been, I don't know if it was a hot topic, but I would like to believe that I believe there was like 2 or 3 talks on KubeVirt in CDS. Anybody attended a talk on KubeVirt yet in CDS? Very nice. Okay, there is actually, so that's nice to hear and see. So so in your daily work, how many of you basically work with virtual machines? Wow, that is super awesome. I was actually a little hesitant to speak about KubeVirt because this is container days, and there is an irony always between containers and virtual machines. But I think quite a few years back, I mean, at least I was in that bandwagon where at least I thought, okay, nobody's going to use virtual machines. Everything is going to be containerized. It's going to be fully Kubernetes, but things couldn't be further from the truth. And I think the audience, you actually even, I would say, solidified that thought of mine, because quite a lot of people, I think I would say at least 60 to 70% of whoever is here is directly working with virtual machines, even in a container age, right? So which kind of reaffirms the importance of virtual machines in different ways. It could be maybe a legacy application. It could be the way your app is refactored. It could be a possibility that you're trying to get out of VMware. It could be something related to you're trying to make your own public cloud. So so like I said, the possibilities are immense. It's really and Kubernetes and virtual machines, I think it's a really powerful mix when virtual machines are being introduced into our Kubernetes ecosystem. And the power of Kubernetes, the resilience and the self-healing of Kubernetes, I think it just amplifies the use of virtual machines is what I felt very strongly last year. And it's also nice to see your containers and virtual machines living together happily without any fights. They are harmoniously living together. So it's nice to have all these in a single platform as well. So, all right. context. So I don't know if who else had, so this slide wasn't there. I added it yesterday because I really liked how Kelsey on the first day talked about the importance of context. Especially, I think he did a live demo in the talk, and he basically showed what does even an AI model can give you with and without context, and it was a really big, stark contrast. And it kind of gave me this thought process that I think when you're speaking to human beings, you should have a deeper context, a larger and a more articulate context. Only then and I also don't believe in, like jumping into the topic theoretically like that. So in terms of context, a little bit about what I said earlier. The need for virtual machines. VMware, I think, was one of the pushers for this trend that we are seeing. We've had a lot of customers who have wanted to migrate their ecosystem from VMware to another compute platform that can support virtual machines, and even better if it's in Kubernetes, right? So there has been a growing trend, and we have successfully implemented a few of those migrations within our organization. But it is not really very easy. It's not an out-of-box solution. You need a certain expertise with certain tools. And when I talk about tools, the centerpiece of this, the entire stack is KubeVirt. So that is where I would say, if this is on a VMware context, KubeVirt would be something like vHost-D, host-D. I'm not, I mean, I could be wrong, but it is one of those centerpieces that makes this entire thing run, right? And there are add-ons that you can use to make it, give you a more vCenter, VMware kind of an experience. Like there is a CNI called KubeOVN. Anybody knows KubeOVN over here? Show of hands. Anyone? Okay, all right. It is actually a really cool CNI. I wouldn't say it's really that mature, but it's extremely powerful, and it almost gives you that maturity of a VMware when it's coupled with KubeVirt. So that's the introduction, basically. On how we came to this point and how KubeVirt becomes the centerpiece. And I wouldn't say I'm an expert in KubeVirt. I'm here to talk about a small feature. I think it is one of probably the most useful, I wouldn't say maybe not most useful, but it's probably in the top 3. Live migrations. So I want to talk about live migration. So I'll be talking exclusively on how live migration works in KubeVirt environments, right? So I want to tell a small story. So I think probably 10 years or 8 years back, I was using VMware or vCenter for the first time. So it's that, I mean, VMware was already quite mature at that time. It was really powerful, but I was late into that game, and for the first time when I was using vCenter, I saw something called vMotion. And I asked my manager, is it fine if I just test it? I mean, I'm really curious because everybody in my team was trying to upskill ourselves on vCenter as well. So I did it. I kind of vMotioned a VM read a few docs so that I don't screw up the environment, but I kind of did a vMotion that day. I still remember that day, and my mind was blown. Migrating a VM from one physical host to another without the most minimal downtime. It was magic to me, and I think I was working from home that day. I was so excited. I went to my wife and I told her, see, this is something I just did. I just magically like migrated a VM from this host to this. And for context, my wife works in finance. And she, sure, babe. Yeah, I'm really happy for you. So I still remember that, and I was so excited that I didn't catch that. And then, obviously, after a few weeks, one of our conversations, she told me, okay, I was, like I was really happy that you were excited, but yeah, I didn't understand whatever you said. So, so that's the story about emotion. But I literally felt like it was magic. So right now fast forward to a present time, it is a de facto feature for any of the platform, I would say. There is vMotion, there is, when I was to work for Nutanix, they had an operating system called AHV. So those are all, I think, libvirt, KMU, live migration stuff. And now, like I said, it's a very de facto feature. But I think in Kubernetes, this is probably a first. And we are here to find out how does that work behind the hood in Kubernetes, specifically live migration, something that can, if done well, can save your day. And if it doesn't work, that can explicitly ruin your day. So it would be nice if we know what happens in the backend. Right. So I'm absolutely sure I don't need to explain this slide at all, because this is exactly what live migration is supposed to be. It is, like I said, teleportation for VMs, expecting there is no downtime. It is, I would say, the most minimal downtime. Because I have continuously pinged multiple times, and I do see. I mean, there are. I wouldn't say that it's like a zero downtime, but as much as possible, there is probably no downtime. There is a certain phase when the cutover happens. So I think that's 1 millisecond. And in my testing, what I found is if you use this KubeVirt, that goes to less than 0.5. Millisecond, which is super awesome. That's the reason I said it's a very powerful, I think, underutilized CNI. So yeah, it's open source as well, so free feel to do a test drive. So again, it would be transparent to the guest. So these are really basic stuff what a live migration should be. And the use cases are mostly your hardware maintenance. It could be load balancing, or if your nodes are draining, or if you feel that, okay, this node is going to die and you want to migrate it as soon as possible. So these are the few things. So now let's get into the architecture. So this is the architecture from a KubeVirt perspective. So if I want to talk about a KubeVirt architecture, it would be a much bigger diagram. So I'll just be talking about the components that's directly involved in live migration. As you can see, there is a word controller. It is basically, I would say, so let's make this slightly more fun. Let's take an analogy of a moving company, right? Everybody once in your life would had to deal with movers and packers. So, and there are days when you wish that you didn't, but I'm sure everybody had, and there are different people that have different responsibilities in that. Let's call it the migration crew, right? So, okay. So yeah, so now let's talk about our live migration crew, right? So this guy is a move coordinator, okay? So he watches everyone. He kind of delegates everything. He looks at the status of what everyone has done. So this guy basically is probably the guy with the most fancy cap, and he has a board in his hand, and he basically deliberates and coordinates everything. Now the word handler. So word handler is actually, it runs as a daemon set in every node. We can, for making it simple, we can maybe compare it to, let's say, kubelet. So let's say this is kind of kubelet for the KubeVirt ecosystem, right? So every node will have one word handler. And in this analogy of a moving company, this would be the lead loader. So when I say loader, it is the guy who basically packs up your boxes. from the source, right? And then you need someone to unpack it as well on the destination. So like I said, you're talking about 2 nodes. There'll be one word handler per node. So there will be someone who packs and then someone there who will unpack. And the word launcher. Now the word launcher, there is one in your source and there's one on the target. Word launchers are multiple. There would be, so these word launchers are basically your pods, and every time you want to spawn a VM, you would need a word launcher because your VMs run inside this word launcher. And the word launcher is nothing but that encapsulates, it's a pod that encapsulates your virtual machine and that can host your KMU, right? So the KMU is where the virtualization happens, that's the virtualization layer, and word launcher is the homeware that runs. So, right, so those, let's maybe compare them to the drivers of the truck. And now KMU or libvirt is, I would say, the magical piece in this equation, because that's where the actual migration happens, right? So if I go to, let's say, this diagram, okay, this diagram, the actual migration, as you can see, happens between the source and the destination KMU, right? The word launcher, like I said, there will be a pod for every VM, and the word handler, for the most simplistic way, you can compare it to maybe a kubelet, because there will be one word handler running per node, right? And another important piece is the domain notify pipe, right? Now these components, right? They are quite tightly coupled, I would say. And the most important communication would be between your word launcher and your word handler, right? Like I said, word handler is that guy that lives on every node for KubeVirt. And word launcher, you would have multiple word launchers. That would mean that every VM would have a word launcher, and the communication between the word handler and the word launcher is really important, because most of the times the responsibilities could be overlapped. So I would say the word handler, basically most of the time, it tells word launcher to do some stuff, and the word launcher is basically supposed to tell word handler, okay, dude, I just got this done. I'm ready for the next. So the actual migration is the tasks that KMU has to be done. It needs to go through the word handler, and it needs to talk to the word launcher. So that communication is extremely important. Hence the reason we have a domain notify pipe, which would basically track any migration updates, agent events, and it also tracks the lifecycle of this communication. Right. So now that you have met our crew, let's move towards what each of them does. So now we are going to go one level deeper. I did say that word controller, it would be like a move coordinator, right? Like a move coordinator. Now, what does it do, right? Now, this is also, we are going to go one level down, and I think after 5 minutes, we'll go probably one level down more. So, as you can see, word control, so something triggers the migration, right? It can be 2 ways. It can be either from a user. A user can just run a command, wortctl migrate this VMI. That's one way to live migrate, and it can be migrate, or a migration can be triggered by KubeVirt when you want to, let's say, do a node draining of some sort, right? And then the KubeVirt itself, or the cluster itself, starts that migration process. So when you trigger a migration, the first thing that gets created is a virtual machine instance migration CRD, right? So that's so we'll just get to so it's called VMIM, a virtual machine instance migration CRD. So it's actually a resource that would have the spec of the VMI that it's trying to migrate. The word controller catches that as soon as this VMIM is getting created. The word launcher sees it, and then it tries to pick a target node. I think it also uses the help of the Kubernetes scheduler to find the target node, basically to see that there are no conflicting tains and stuff like that. All right. And the next one would be, I would say, the word handler. Excuse me. All right. So the word handler, like I said, it's actually there are two word handlers, one on the source and one on the target. I would say those are basically your packers. It basically talks to, on the source node, it talks to the KMU to start the migration. And it kicks off a pre-copy. Pre-copy is nothing but the transfer of your memory pages before the migration, right? And then it coordinates the final stop and copy cutover. On the target node, what it does is it prepares the environment to receive that memory pages. It also prepares the environment to receive that migration information from the source KMU. And it helps with the cutover, handover as well. So word handler, I would say he manages what on the migration side on every node. It talks to the word launcher, it makes sure the KMU does stuff. So I would say word handler is the manager on that node, right? Now, there is the word launcher, like I said, the word launchers are like the drivers, right? So basically, there is a source VM that would be inside a word launcher, and then there is a target that would be migrated. That will also be word launcher, and that essentially runs the KMU, which actually does the migration. And there is one in the source and the target. It also basically helps in the pre-copy, and then it helps in starting the KMU in a receive mode on the target mode, and then it also helps with the stop and copy. So word launcher, again, it interacts a lot with KMU to make sure that the migration goes without any issues, right? So now the actual guy, which is the truck itself. So I would say this is the person who actually does the migration. So it leverages a function from libvirt called migrate to URI3. Earlier it used to be something called vdomain migrate. But I think because of new dependencies, now they have the libvirt, they have migrate to URI3. And this person, KMU, go ahead and it does the pre-copy, and it makes sure that the CPU resources are correctly, there is no dependencies on CPU. If the masking if you have different CPU models, the masking is working correctly, stuff like that. So, but the major function of KMU is to start that pre-copy, which is start sending your memory pages from the source to the target. Right, now let's quickly go into the sequence of migration. Now we are going to go one level deep. So like I said, something that triggers migration, it can be either with a wortctl command, or it can be someone that is creating the virtual machines instance migration. It can be from the system, or it can be something that can be triggered by the node as well, but as a part of a node training. It lives in the same namespace as VMI, and the VMIM will have, if you look at, or if you do a OYAML output, you'd see that every instance migration resource would have a spec of the VMI that it's trying to migrate. Right. So, and then once it gets created, like I said, the word controller, which is the move coordinator, it watches it. It tries to select a target node using this scheduler, and then it spawns it also helps in spawning the word launcher or the target VM. So as soon as you start your migration here, a dummy or a shell VM is already created in the target side, and it updates the status. It basically coordinates and watches everything. now, the pod scheduling. Now, like I said, it detects the word control detects the VMIM and it picks the target node. It creates a word launcher and it makes sure that there is an anti-affinity set between the target and the source, so that they are not scheduled on the same node, right? And it also tries to mirror the VM spec in terms of CPU, memory, the volumes. It should be RWX, and yeah, if it's not shared storage, then it basically prepares itself for the block migration as well. It also create a pod disruption budget, so that at least one of the source and the target is always running, and because we don't lose both. Now, when you're preparing the destination, again, the same thing happens on the other side as well. How the word handler initializes the libword, the KMU in a receiving mode, right? And it also make sure that the migration target is listening. So basically, the migration target, the VM that's created on the target, it has to have certain IPs and the ports open, so that the migration information is correctly wired, so or correctly received. Now it happens on a couple of ports, and the KubeVirt basically make sure is that it basically facilitates that connectivity between the source and the target KMU as well. That happens in pure TCP and on network ports. Now, like I said, there are ports that would be used for transferring memory pages. 49152 is used for transferring memory pages, and 49153 is used for optional block copy. Optional block copy means that if you don't have a shared storage, that means that your entire storage would will be transmitted to the target through the network. It's a very painstaking process, because it would also depend on how big, how complex your data is. But it's basically cut, copy, paste. But yeah, if there are different complications, that's actually part of it as well. And also, it also makes sure that the target VM is on an empty shell until the final cutover, until the final migration is done. Now, this is I would say, the most important part, which is the pre-copy. The source word handler basically starts the libword migration and opens the stream to the target KMU. That basically means that it makes sure that the source KMU and the destination KMU is talking to each other, or it's in a position where it can go ahead and transmit the memory pages, which is essentially the most important part of the entire process. Dirty pages. That's actually a really, I would say, a complicated part of this migration. The problem is, when you're transmitting memory pages, your application is still writing data, and depending on your application, it would depend on how aggressively the memory pages would be written, right? So the dirty pages are the memory pages that are written during this migration. So if I want to give a very simple analogy, if you have kids and if you're at home, and let's say you're cleaning your house alone, and then you have a toddler who is making a mess of things, and as and when you're cleaning your house, your toddler is basically making a bigger mess. So what you do is you basically pick up the kid, and then you do a cleaning, and then after the cleaning, you put him back. So that's what at least I do in my house. So, so that's that toddler making that mess. That is your dirty pages, right? So during a migration, you kind of try to minimize that inflow of dirty pages, because if dirty pages is equal to the rate of migration, then it's a never-ending migration. It can just, for all you know, go run for a really long time. Right, and yeah, so that's basically, and the CPU also is also registered. It makes sure that you have compatible CPUs, and yeah, that's basically it. And like I said, without shared storage, the entire block would have to be migrated on TCP port 49153, and which is not very ideal. I would say shared storage would make your life easier. Now, copy. This is again how the copy and convergence happens. So as you can see, the pre-copy is basically when the memory pages or the dirty pages are being migrated from source to the target. Now, a very interesting term called convergence. Convergence is basically where the source data and the target data, it comes together, and okay, now we have a consensus on, or we have a grasp on the data. The data is migrated completely. That's what you call as convergence. Now, the dirty rate should always be less than the bandwidth itself. Otherwise, if the dirty rate is more than the bandwidth, then it's, like I said, it's a never-ending migration, right? Now, there are a few tricks that KubeVirt does to handle dirty pages. One very smart feature is auto-converge. So it goes back to the analogy I mentioned about the toddler. So auto-convergence basically means that you slow down the toddler, so he makes less of a mess, and then you have a bigger rate of cleaning. And at some point, the mess is going down, and the surface of cleaning is more. So basically, what it does is it's literally slows down the CPU of the source VM, so that it like makes less of dirty pages, and then we can get the OK pages or migrated, and then it basically slows down the CPU so that that inflow of dirty pages goes down, and we are able to reach a convergence. And post copy is again, it's just opposite of pre-copy. Post-copy is when the migration, so the migration is immediately done, and then the data is migrated on demand. So the memory pages, so there's a small risk for post-copy. The problem is if it's a continuous process, right? And if there's a connectivity problem between the source and the target, there's a good chance that it can, delay or affect your migration, so to speak. Right. And yeah, the switchover. This is the most easiest part, I would say. As and when the pages are migrated, there is a cutover process that happens, and it converges into a very small delta, and the libvirt briefly pauses the source VM so that the cutover process happens, and the VM basically resumes on the target with near zero downtime, and the source process exits. And the Kubernetes servers and the DNS all remains stable. And if you use Multis, which is like a secondary CNI, you can actually retain the same CNI as well. You can do with that with KubeOVN as well. And the completion and cleanup is basically, remember the port disruption budget I mentioned, that would be deleted. And the source word launcher port would be, that was there, that would be completed, and it would be removed. And again, if you look at the VMI status, it shows all the timestamps of your migration and things like that. And if it is cancelled or failed, if the migration is cancelled or failed, the VM keeps running on one node. Most of the time it's on the source node, because I have not seen a situation where it got cut and it is stuck on the target. It mostly falls back into the source part. Migration, zero network interface. It's a quite important factor. I mean, if I want to relate it to VMware terms, it would be one of the vSwitch specifically for your vMotion, right? So this is something like that. You can migration. There's a dedicated network interface for your migration. So there are two choices. Either you can do it on your default interface, but this would be a more production setup to use a dedicated, and KubeVirt provides the scope for it. You can actually use this particular dedicated network interface to actually conduct your migration, and you can do it through multis. You have to attach a network attached definition that would help you do it. Also, it's a really smart way to isolate your VM state transfer. Yeah, it is. I would say it is probably one of the good best practices. Now, there are a few migration network and tuning parameters that you can do. One is the bandwidth per migration, and the administrators can actually adjust its value cluster-wide or migration, and it is basically the throughput per live migration. And there's also this bandwidth control that you can use. It caps the throughput per live migration so that a lot of the throughput is not used. And there's also, you can use timeouts. There are completionTimeoutPerGiB that bounds the total time by VM size. And there is something called progress timeout fails. It basically, it fails when there is no meaningful transfer for a particular time. Right. Just give me a minute. I think I have some duplicate slides. Okay, I think we are towards the last part of it. So one last topic is the TLS toggle. The communication happens through TLS. You can switch it off and basically make it faster and make it less complicated, though not recommended. We can do it basically to speed up things. Some real life scenarios that I mentioned in the beginning: node maintenance that actually creates or that actually triggers this live migration. And if you have heavy workloads, it may not convert, may not use or pre-copy. Maybe you'll have to use post-copy so that the memory pages are migrated on demand. Yeah, and again, you can also limit the concurrency with parallel migrations per cluster and per node caps to protect your peak capacity. This is again, it comes back to the use of migration zero. Disaster avoidance is again, I would say, use your dedicated networks, and it makes sure it kind of sandboxes your entire migration experience. Sorry, I had to kind of speed off through the last few slides, but please feel free to go to the KubeVirt. The documentation is really awesome. So if you have doubts, yeah, please, happy to answer. Sorry.
Are there limitations in terms of amount of VMs that can be moved at the same time?
I wouldn't say there is a limitation, but we can set a limit. Again, I wouldn't say, sorry, one sentence. No limit, no hard limit, but not recommended to go overboard. This is what I would say.
Awesome, thank you, Ronny. Do you have any experience with cross-cluster migration, or is it even supported?
Cross-cluster migration is not supported yet. You'd have to use forklift to do so the solution is not that mature as of now. So right now it's not there, but if you want to venture it, use forklift. Talk to me. We are doing it quite aggressively in our organization. So if you need cross-cluster migration, happy to guide and talk about that. Yeah.
Awesome. So last round of applause for Ronny.
From ContainerDays Hamburg, this video is proudly presented by DAX IT.